Hi, my name is Victoria Kimbrell, and today I will be explaining the concept of motion. Let's start off with the laws of motion. More specifically, this guy's, Sir Isaac Newton. Newton's first law states that an object in rest will remain at rest, and an object in motion will remain in motion in a straight line at a constant velocity, unless acted on by an unbalanced force. A good example of this would be the Voyager 1 spacecraft. Voyager 1 was launched in 1977. That was like 40 years ago. And guess what? Because space has no friction to oppose the motion, it is still going. At the same speed, in the same line, at the same constant velocity from when it was launched. And it always will be, thanks to Newton's first law. Newton's second law is that in a presence of a net force, an object experiences an acceleration. This can be represented by the formula force equals mass times acceleration. Finally, the third law states that for every force, there is an equal in magnitude and opposite in direction force. For example, as a rocket takes off, it expels gas in the direction behind the rocket. This force creates an equal and opposite force pushing the rocket forward, known as a thrust. See, motion is easy. It's not rocket science. Now, guys, it wasn't that bad, but I've saved the best example for last. Give me a drum roll. Pushing a cart. I know, sounds ecstatic, but don't roll your eyes at me yet. It's actually more complicated than you'd think. According to the third law, every action has an equal and opposite reaction. Forces come in pairs, like we saw with the rocket. So if I push on this cart, it goes in the opposite direction, but it's pushing back on me with an equal and opposite force. Shouldn't the forces cancel out? Why does the cart even move at all? Our answer is in friction. Because of the friction here on Earth, if one object is much more massive than the other, all the acceleration is imparted on the second object. So let's get back to me in the cart. Because my feet are exerting a force on the earth that is external to my hands in the cart, the earth in return is exerting a force on my hands and the cart, which causes a force onto the cart. And as Newton's second law states, in the presence of a force, an object experiences an acceleration. In turn, the cart then moves in the way I am pushing it. I'm Victoria Kimbrell, and thank you for watching.